Hi everybody, welcome back to our video series on the new 2023 National Building Code Alberta Edition. My name's Daryl Paul and I'm a building envelope specialist, and I'll be hosting this video for us today. We want to talk specifically about multifamily in this video. Now, in earlier videos, we talked about things like performance versus prescriptive. We talked about things like airtightness. We talked about all the different aspects of the building code, but specifically related to single family construction. We want to talk today about multifamily and why it's so different than single family when it comes to the energy code. Things like airtightness, things like energy efficiency, things like how do we do the modeling, and should we use prescriptive or should we use performance? So come and join me as we go through this. Let's get started.
Now, when it comes to energy code requirements for multifamily,
We're dealing with a Part 9 building, but sometimes we deal with a Part 3 building. So what's the difference? Well, a Part 9 building doesn't require extra engineering. You can build it as per the code unless you go outside the parameters of the code. So when we deal with energy, we're dealing with what we call Part 9.36 or Section 9.36. And that doesn't require us to have any engineering for the energy portion of the code. So we can do performance modeling, or we can do the prescriptive, which is the X for the walls, X for the roof, X for the foundation. Now, if we want to go into Part 3, it's still multifamily, but it changes where we follow how to comply with the code. So typically for a Part 3 building, we're going to use Part 3 of the building code. We're going to fall under either an engineer or an architect, typically an architect. And those individuals will determine which consultants to use to produce the energy model. But the energy model we use is from the NECB, or the National Energy Code for Buildings. That's slightly different than the Part 9.36 or the Part 9 Energy Code. And the biggest difference is that the NECB has to be done by an engineer, has to be reviewed and stamped by an engineer. So that's the difference between the two. So for today, we're only going to be talking about Section 9.36, which is the Energy Code for Part 9 buildings. Now, sometimes people question which one should I use? Well, here's the trick. You can use NECB for any building, single family or multifamily. The difference though is how you get to the numbers you need to get to. So for instance, for a Part 9 building, your average is about R17 effective for walls and about R50 effective for the roof. If you build under NECB, you're dealing with an effective R27 for the walls, but only about R36 for the roof. The difference being there's usually a lot more windows in a commercial building, and those windows have a lower energy efficiency than in a residential building. So other than that, we're really not going to get into NECB. We're going to deal specifically with Part 9.36. Now, what are the changes in the building code, in the 2023 National Building Code Alberta Edition, that are going to affect us? Well, we touched on the performance versus prescriptive. And again, once we get into that aspect of 936, we have those two options. And in an earlier video, we talked about what those options are in terms of how we achieve compliance, whether it's prescriptive or performance. And don't forget, under prescriptive, we also have the option to trade off. So we can trade off between the two of them. So we're not going to get into too much detail in this video because we have a previous video on it. Now, once we go through that, then the next section we talk about is the tier codes. Now, you might recall from earlier videos that we talked about the tier codes being new to the 2023 code. With tier codes, we have 5 separate tiers. In other words, we have the code as it's written, but then we have tier 1, 2, 3, 4, 5, which progressively improve both the energy efficiency, so the building envelope and how much insulation we put into it, but also the overall performance. So once we get to tier 5, we're into 40% improvement on the building envelope, but we're actually into 70% improvement on the overall structure. So that's the tier codes. Now, currently, Alberta has not adopted the tiers in 936.7 and 936.8, which means we're at tier 1, technically. So we don't have to do anything other than what is written into the code. Now the tiers talk about a couple of things. One tier talks about, or not tiers, but the sections dealing with tiers talk about a prescriptive movement of the tiers 1 to 5, and the other one is performance modeling from tier 1 to 5. So that's the tier section of the code. The other thing we talked about in our last video was airtightness and how important airtightness is and where the airtightness can make a difference. Now, this is really where multifamily separates itself from single family, because airtightness becomes really, really important in multifamily for a variety of reasons. So for instance, when we talk about party walls or demising walls, you get a lot of air leakage through them. So the question is always, what about the difference between that air leakage when it comes to energy versus things like odor or sound? So we're going to explore that today from the specific aspect of multifamily. And if you're doing single family, have a look at the previous video and we can talk about that. So that's kind of a high-level overview of what some of the changes are in the code and what we've talked about in the past. So let's now get into the multifamily aspect that we want to focus on for this video. So let's talk first about energy modeling and the difference between multifamily and single family. Now, as you can imagine, if you're doing a single family building, you're dealing specifically with just the 4 walls and the windows within those walls, with whatever insulation goes in there. Now, when we take that house and we rotate it certain directions, depending on how much glass is in that wall, what the ratio is, and depending on what the energy efficiency of that glass is, or the walls, that can change what the energy efficiency of the building is modeled to. So remember that when we're dealing with windows, we get free heat in the wintertime, which will improve the overall efficiency of the house. The more free heat we get, the easier it is to meet that energy efficiency standard. But remember, the opposite is true in the summertime. That heat can also cause problems with overheating. So we need to block that out. So when we're designing and looking at the model itself, we can turn that. Now, if we're doing prescriptive, turning the house doesn't matter. It's the exact same no matter what direction. Whereas when we do the model, it really is impacted by the direction we put the house. The reason for that is because of the ratio of window to wall and the solar heat gain of the windows. So one of the things with modeling or energy modeling, which differs from prescriptive, is that we can change the values to give us a performance model specific to the way the house is positioned with regard to the sun. So for instance, if we're building to a prescriptive formula, we put X in the roof, X in the walls, X in the foundation, and X in the windows. And when we do that, it really doesn't matter which direction we face the house. But what happens when we're energy modeling, we can take advantage of the positioning of the house, which could be good or bad, depending on your perspective. So for instance, if you put lots of glass on the south side of a building, you get lots of free heat. Now, free heat in the summertime is not good. We don't want that. But we do want the free heat in the wintertime. So changing that direction will completely influence how that house performs with regard to the heat from the sun. And the reason for that is we have what's called in windows a solar heat gain coefficient, which is SHGC. And the amount of heat that comes from the sun through the glass into the house is influenced by that. Now, with a single family dwelling, we have a little bit of variance in how we can adjust the angle depending on the lot or the positioning. But once we get into multifamily, what really becomes an issue is when we place that building on the lot, then that impacts the amount of sun, because typically we're only dealing with 2 sides. So if that multifamily unit happens to face south, then the glass on that side of the building can really impact the energy efficiency of that specific unit. The other thing with modeling too is think about multifamily from the standpoint of single family. We have 4 walls to work with. And we can adjust all of the 4 walls. We can adjust the heating that's coming through the glass. But with multifamily, the end units might have 3 walls, and 1 wall is being shared with other units. But what about the middle units? Now those are being shared with other units, so we only have the exterior walls to deal with. So it's more energy efficient for that specific unit in the middle. But the downside to that is if all the glass has to go on that specific unit, then we get a ton of heat in the summertime, which we don't necessarily want, because that leads us into something we're going to talk about later, which is peak cooling loads. So when we think about how we model a building, the difference between single family and multifamily is really important to understand when it comes to how it performs and what is the best method to use. Now, one of the other things to think about with multifamily is the percentage of glass. So there's a window wall ratio. And when we're below that 17 to 22% window wall ratio, we're getting a credit for everything that's below that. So on our end units, we're dealing with 3 walls. We get a really good credit if we're below 17%. Now, if we compare a single family house, for instance, most single family houses are somewhere between 8 and 12% in the Alberta market. Now, that's for a standard ordinary house. If you're into custom homes, that number changes, but somewhere around 8 to 12%. Now, with that number, we get a huge credit towards our energy efficiency when we do performance modeling. If we exceed 22%, we're penalized when we're over that number. So if we're doing multifamily and we're doing back-to-back, let's say we have 6 units on one side and 6 units on the other side, what happens is we have to put all the glass on that one single unit. So depending on if it faces into the sun, we could overheat it in the summertime, but we get free heat in the wintertime. It might perform really good from an energy model perspective until we have to cool that unit. But it's the percentage of glass. So we either get a credit or we get penalized for that. So the window wall ratio becomes really important and really critical when we're modeling multifamily units. Finally, we want to talk about airtightness. Now, with a single family unit, it's pretty simple to get good airtightness, and it's simple to test for airtightness because we really just put a blower door in, we depressurize the house, we measure the air leakage, we know that all the surfaces in that building are influenced by the air leakage. But we also know that we have quite a large area that we're dealing with. So we're not dealing with, per square foot leakage, we're dealing with ACH, or air changes per hour. When we deal with air changes per hour, the volume of the unit makes a big difference. So an average volume for a single family home could be 25,000 to 30,000 cubic feet. So that's exchanging the air. If you have a 1 ACH, that's exchanging 25 to 30,000 cubic feet every hour. But once you get into multifamily, you get into smaller and smaller spaces. So if you're doing, say, a 5-unit row and you have 2 end units, those end units only have 1 party wall. So you're dealing with air tightness of the perimeter. So you're probably going to have fairly airtight construction because you only have a party wall from one side to deal with. Once you're into the middle units now, when you're doing air tightness, not only do you have a smaller space, so probably around 12 to 15,000 cubic feet. So you've cut that volume in half as compared to a single family. So now the number really goes up when you're doing your ACH, but you also have 2 walls to work with. So typically on multifamily, you'll have the end units will be more airtight than the center units. So that can influence, if you have a neighbor that's on an end unit and then the neighbor on the first inner unit compare their EnerGuide ratings and they go, well, how come I've got 2.5 ACH and you've got 3.5 ACH? We did the construction the exact same way, but because the end unit has less party wall, it's going to be more airtight. So that's why it's difficult to do multifamily, get the air tightness down where you want it to be the equivalent. So in the building code, what they've done is they've addressed that by saying your reference house in single family needs to be 2.5 ACH. In multifamily, they now allow us to be 3 ACH for multifamily when we have those connected zones between each other. So that's going to help us with our energy efficiency because our comparative is 3 instead of 2.5 like it was in the previous code. So those are some of the key differences when we talk about multifamily versus single family when it comes to energy efficient and doing energy modeling. One of the most important or the most challenging issues we have between single family and multifamily is the mechanical room. Single family, it's pretty simple, but look at the mechanical room behind me. This becomes a real challenge in multifamily. This example really illustrates some of the challenges with how do we put a mechanical room, which really is supposed to be part of the conditioned space, it's supposed to be heated. How do we integrate that with a garage that's unheated and then tie it in where we have a bonus room above, we have a party wall behind it, and now we need to make that airtight? Because remember, all of these ducts that are going through here are going to somehow connect from the unconditioned space to the conditioned space. So we need to tie those together. So just imagine with these ducts where they're going here, how they're going to move from this location in the garage in through the common wall of the house, and then they have to move upwards into the upper section of the house. So now everywhere there's a bit of an air pressure differential, so for instance, stack pressure or mechanical pressures, or even wind pressures for that matter, you will have a pressure in the closet or in this room here that is different than the garage. You'll also have a pressure difference in the connection all the way up. So not only do you have to make this box airtight, as you move through, you have to compartmentalize so that the air that's in here doesn't interconnect either with the floor on the next level or the floor above that. And so that's one of the challenges that becomes really difficult to get a good detail on, because you have to explain it to the framer, to the mechanical person, to the electrician, to the insulators, and anybody else involved with it. So spending some time and thinking about this is very important. You will not be able to do this with just a blueprint. You'll have to come out on site and do some mock-ups and walk through to understand the most efficient and effective way to be able to detail this area. Oh, and one more thing, just to be clear, the reason that this is so important to be airtight is the fact that we have carbon monoxide risk within a garage. So we're really good on the common wall doors and walls at getting good air tightness in that location, because we know it's a serious health and safety risk. With this kind of construction, we need these airtight doors, airtight construction, because this ties in, remember, to the rest of the house. This is a heated space, and this becomes a serious health and safety risk if we don't properly airtight this location. So let's not forget that it's not just energy efficiency, it's health and safety as well. Now, one of the other challenges is you can see that we've got open web joists. The difference between open web joists and closed web joists also impacts the air tightness, because here, this is wide open for the air to flow through. Now, it's a huge benefit for heating that floor in the bonus room to keep it warm, but how do we get it airtight? So we're going to discuss air tightness of bonus rooms and party wall connections a little bit later in this video. So one of the other challenges with multifamily over single family is what do we do with penetrations? And particularly we're talking about mechanical penetrations. So as you can see, we're looking at mechanical penetrations in a building that has not only side-by-side units, but also has stacked units. To be able to have enough venting is a challenge. When you're putting venting through for a single building or a single unit that needs an exhaust and intake for an HRV, that needs an exhaust and intake for a furnace, an exhaust and intake for a hot water tank, you have a significant amount of penetrations through that wall. So that has to be considered when you're doing the energy efficiency calculation, which is important, but also how do you vent these things? Are you eliminating the HRV? Well, that's not a great idea. That's not a great option. Are you eliminating maybe one of the penetrations so that you maybe use a combi unit? So you use electric hot water tank or another solution. So you have to think about those things from the standpoint of what not only meets the code, but what can you do on a building like this when it comes to the penetrations? Now, the penetrations are mostly the mechanical, which make a difference because the new code, remember, limits the distance between where the exhaust or intake are and where that soffit is. So you also have to consider cantilevers and other components like that. So as we continue talking about the difference between single family and multifamily, what you can see here is a typical example of what can happen. Now, with this example, we have garages here that we're fastening all these systems to, and we have penetrations which go through into the garage. But if you don't have garages to connect all this to, then what you end up with is having to run penetrations for gas lines and electrical through a conditioned space or a conditioned opening. So again, we want to be careful about how we're detailing that, because that affects the air tightness of the building. Now, when we look at these, we have multiple connections where it's going through the wall for the gas lines, but also when we look down here at the electrical, we not only have these connections that are going through, but we have how we deal with water and shedding water that's coming from above. So that's another difference that we have to take into consideration, single family versus multifamily. So one of the things to consider is the new requirement in the code for peak cooling loads. Now, what is peak cooling loads? Well, what happens is when you get too much sunlight through the glass is you can actually overheat that building. And the problem is that it's causing serious health effects. So we can't have too much overheating, because that affects people who don't have the ability to either get out of the building or because they don't have air conditioning. So a peak cooling load is really a way to determine at certain times of the year when it's summertime, is it going to overheat that building? Now, what you can see here is a really good example of what happens when the sun hits that building. And the biggest difference between single family and multifamily is the amount of glass and the amount of heat that generates within that building. So think of it this way: when we have multiple units, but they're back to back, the majority of the glass goes on one side of the unit. So when it's like this and we have lots of shading, it's not a big deal. But if we're in full sunlight, such as we have here, you can see that there's a tremendous amount of heat that could be generated during a hot summer day. So when we have a single family house, we usually have a smaller percentage of glass on one given area or one given room. Whereas once we're into multifamily and we're into units like this, where we could have stacked units or we could have side-to-side units, we're getting a tremendous amount of heat on that side of the building. So the peak cooling load becomes a real challenge to be able to do the energy model and not overheat the building. Now, when we do the energy modeling, we will get that calculation from our energy model, and we'll know right away if we're overheating that building or not. So that's one of the prime things to think about when it comes to peak cooling loads. Now, we're going to go into this in more detail in a further video, but for the time being, this is an important aspect that's very different between single family and multifamily when it comes to peak cooling loads. So one last thing before we move on to air tightness. When we talked about penetrations, part of that was windows, talked about peak cooling loads. But if you look at the windows with multifamily, one of the things to think about is the comfort of the occupant. Now, with energy efficiency, a lot of times we rely on an HRV for fresh air, but if you think of a multifamily compared to a single family, typically in single family in the summertime, we can open the window on the front of the house and on the back of the house. Well, a lot of times in multifamily, we don't have that option either, because we have an opening window here to vent, but we don't have a vented window on the other side because there's a unit on the other side and there's a unit on left and right as well. So that's one thing to think about when it comes to multifamily ventilation, getting fresh air into the building. So let's talk about air tightness now. To introduce air tightness, think about the efficiency of the building from this standpoint. Air tightness is one of the easiest ways to improve the energy efficiency. In fact, moving from a 2.5 ACH down to a 1 ACH will give you about a 12% increase in energy efficiency. So that's huge. Not to mention the other benefits of having air tightness. Now, with multi, it's slightly different, because in multi, we also incorporate party walls. Now, the argument has always been, well, if the air leaks from this unit to the next unit, what's the big deal? It's heated air moving to heated air. Well, that's part of it. But the other part of it is the fact that sometimes between the party wall, there's an interconnection to the exterior. And that's where the danger comes in. So we want to treat these party walls as if they're exterior walls, because we have a connection to the exterior, we have a connection to the foundation, we have a connection to the attic. So those need to be sealed off, because air that gets into the party wall can move into those locations and create moisture issues, condensation and frost, but air from the outside that gets in there can come into the building and reduce the energy efficiency and even create comfort issues. So that's why we need to focus on the party wall as part of the problem. Now, with single family, we don't have so much issue with party walls, but with multifamily, we look at things like plugs and switches. If we look at a plug like this, we have an airtight box that has a rubber seal around it. We use those in single family as well. But did you know that this is a special box for a party wall that has a 2-hour rating? So you're using a slightly different box than you would use in a single family house, even though it's an airtight box. The other thing with the box is you have to air seal that box with a putty pack. Not all putty packs are equal, and not all putty packs are compatible with a 2-hour airtight box. So those are the little things that can affect the airtightness, but also the ability to be compliant with the building code when it comes to fire regulations. So when we look at the party wall, there's a lot of little details that are going to be different for you when it comes to fire protection and airtightness and how these things mesh together. Now, we should mention that airtight boxes are very convenient, but that's not the only option. You can still use a regular old steel box and then put something that's airtight and fire resistant around it. For instance, you can do a 2x4 frame with a drywall backer on it. So there's a number of things that will get you the compliance, but also get you the airtightness that you're looking for. Now, when it comes to the rest of the party wall, if you think of this party wall, we mentioned that, there's an interconnection between units, but also an interconnection between floors. Now, we need to fire stop those between floors, but that fire stopping also is more beneficial when it's airtight. So rather than just putting a piece of tin over where the air can flow through and around the tin and up, keeping that airtight is going to compartmentalize and limit the airflow between units. Now, that can help with odor, that can help with sound, but it can also make a big difference in the energy efficiency, because remember, we're still modeling based on air tightness. And when we do the model, the reference house is going to be at 3 ACH as the mean. So if you test this house and you're at 4 to 5 ACH, you're going to be much higher than the reference, and so you're going to be penalized in your energy model. So those are little details that you need to think about, but going forward, you need to understand how to get there. So you might be better off to do some pre-drywall air tightness testing to see roughly where you are before you get to the final stages, when you don't really have an opportunity to make any adjustments that are going to be meaningful. So now when it comes to party walls, especially with front to back units, as well as side to side units, and sometimes even upper and lower units, let's have a look at some of the things with the party wall when it comes specifically to that type of product. So with the new 2023 National Building BILD Alberta Edition, we do have an air tightness component within the mix. Now, it's important for a building to be airtight because that gives us a fairly good percentage of improvement in energy efficiency when we focus on air tightness. Now, with multifamily though, it's slightly different than single family. If you think of single family, you don't have all these party walls and connections like you're seeing here. So when it comes to party walls, depending on the product you're building in multifamily, if you're just doing straight side by side, that's challenging to start with. But once you do not only side by side, but also back to back, and then you also get into split levels in elevations, now you're getting into fairly complex air tightness. So for instance here, if we look at this detail here, what we're seeing is the main floor is at one level, the floor on the back unit as a different level. Now, in the old days, we used to just put a piece of tin between over that party wall to reduce the movement of air up and down. That was our fire stopping. Now with our fire stopping, we're actually putting in, for instance, like you see here, is a piece of poly that goes here under the wall, up the backside, and across into the other unit on the other side. What that does is it limits the flow of air between floors and compartmentalizes. This helps us with movement of air in between the walls because we don't want smoke or air to rise up, which can have an impact on the fire. But then when it comes to air tightness, this is also a way to compartmentalize to make sure that if there's air between the party walls, which can come in at any of the exterior joints, we don't want that to be influence to be able to spread through the building once it's inside that party wall. So we want to treat the party walls as if they're exterior walls. And when we connect these to the other unit, this is where we bring that poly up and around. So once we get into these different elevation heights and we get into these different connections between the bonus room and the main floor, and then the main floor and other units, now we need to really think about air tightness to start with. Now just imagine here trying to do a blower door test with this type of party wall scenario. If you're doing a blower test on a single family home, you put in one blower door, and one blower door will be able to give you the air tightness of that area. Once you're into a building like this, we can do an unguarded test, which is a one blower door test. But if you look at trying to eliminate which parts the leakage are in, we have to go to what's called a guarded test. Now, if you're just doing units where there's 5 or 6 units in a row, and you do a guarded test, you would put a blower door in the middle, and then you would put one on the left and one on the right. Once you're into a building like this, we have to protect from all areas. So we would have to do a guarded test with the blower door here as the main one. We'd have to put one above, it's a split, but we'd also have to have one left and right, and then on the back corners and on the corners of the back. So this could involve between 6 and 9 blower doors to be able to do a guarded test on a unit like this. So first of all, is that part of your pricing? Do you understand what it takes to do that guarded test? What's the logistics of how you're going to do that test, depending on how you're putting the building together? So there's a huge amount of work that goes into when you think about air tightness in party walls, the difference between multi and single family, but also the type of multi that we're building with. So one of the challenges is when we try and tie in a bonus room floor like this, some of the things to think about, which are different again than single family, is something simple like joist direction, or whether you're going to use an open web joist or a closed web joist. For instance, if you're running joist front to back, what do you do for the air barrier at the end connections? Or if you're using open web joists and you run side to side, that works good for getting ducts and pipes through, but how do you compartmentalize to keep the air that's in the bonus room from coming down into the ceiling, into the insulation where it can sweat and cause moisture issues, or even getting up and above? Because remember, we also want to make sure we deal with carbon monoxide. So we don't want air leakage up into these cavities. You know, you look at a few examples here and you can see penetrations that you have to try and seal. We have cantilevers that are tied in, and those run right through from front to back. Even when we think about splits, like this level here is at the same level as the unit beside it, but in a lot of cases, you're offsetting elevations side to side. So if you have an offset elevation as well as cantilevers, ductwork, all these other things, that makes it extremely challenging. So a lot of forethought needs to go in there, a lot of mock-ups, and a lot of testing to verify that you've got that air tightness. Now remember, when we drop this ceiling, we have to insulate below this, maintain a continuous air barrier, and then we put the drywall on the bottom side. So we have height restrictions, we have to get sufficient insulation underneath here, but we have to maintain this air barrier. So that can be a challenge when we look at something like this where we have a lot of ductwork penetrating into the bonus room of the closet. So now we've tied in the ductwork here. We've got an air barrier that has to go between, and then the insulation and drywall at the finished ceiling go below that. So the complexity of trying to tie that all together is really important. Now, we look at this detail here, we also have the mechanical room, which is tied in. So you're making the ductwork run right through the party wall, or the common wall between the house and the mechanical room, which is now in the heated space. So you start to add these complexities together when you're in multifamily, especially multifamily that is not only side by side, but front to back, splitting it all up so that you only have one unit on one side and one unit on the other side. So all these complexities make it very difficult. So we want to make sure that we get the detailing done so that we don't have problems in the future. So one of the things to think about when it comes to air tightness and energy efficiency is the fact that yes, we can improve our energy efficiency, reduce the heat loss through good air tightness techniques. But don't forget that air tightness techniques also benefit us for things like moisture control and moisture management. When we have air leakage into the attic, that's what causes attic rain. When we think about that from the standpoint of some of the most common complaints in multifamily, that's the transfer of sound and the transfer of odors between units. So if you think about it, when air moves from this unit to the next unit, if you have a radio on, it's the sound waves in the air that transfer through that and move from one unit to the other. So having that good airtight party wall reduces that. When you think of odors and moving odors or smells from different types of cooking or cigarette smoking or something else, it moves from one unit to the other, again, through the airspace that's in there. So by getting us really good air tightness, we eliminate problems with odors, we eliminate problems with sound, we reduce the risk of moisture and, condensation or problems with that, but we also improve our air tightness for energy efficiency. So when we think about it, air tightness is a pretty important aspect, especially in multifamily. So hopefully we've highlighted for you the difference between single family and multifamily, especially when it comes to the changes in the 2023 NBC Alberta Edition. We've illustrated the difference in air tightness, we've illustrated the difference when it comes to penetrations, some of the other key components that really separate single family and detailing from multifamily and some of the things that we have to do there. Now moving forward, we've talked about peak cooling loads to start with, but we're going to in the next video talk more detailed about peak cooling loads. So thank you for joining us. We hope you've learned something about this. Don't forget to download your free copy of the 2023 NBC Alberta Edition, and we'll see you next time.